dimension one-dimensional motion with uniform acceleration. Okay, so since there is acceleration present in this case, it is obvious that we have change in velocity coming into picture. That's the first point. And then we'll follow one convention. The convention is like this. We'll use our regular XY axis to define what is positive and what is negative. So if there is a motion in one dimension, so anything that is moving to the right will be considered as a positive quantity, and something that moves to the left is the negative quantity. Whereas if the one-dimensional motion is defined vertically, right, objects moving towards away from Earth or upwards is considered to be the positive motion, and the vertical motion downwards is considered as the negative, right, motion. Okay, this is the general convention. And now we'll write the equations. So the equations corresponding to the 1D motion with the uniform acceleration are as follows, right? So the first equation is V is equal to U plus AT, right? And the second equation is V square equal to U square plus 2AS. Then we have the third equation, that is S equals to UT plus half AT square. All right, then we have the next term, that is say S1. S1 is equal to the S naught plus UT plus half of AT square. We'll write the terms later. Okay, what is V, what is U, what is A, etc. we'll write later. So let's write all the equations first. Then we have next equation, that is ST or S total is equal to, this is U plus AT minus 1 by 2A. These are the most commonly used equations in one-dimensional motion where the uniform acceleration has to be considered. Okay, now let's move further. So in this case, in all the above equations, U, if I use U in the equation, it is nothing but the initial velocity. Okay, then we write V. So this corresponds to the velocity at any time t. Velocity at time equal to t seconds, right? You put t over there as 4, you get velocity at 4 seconds, and so on. Okay, then the A represents the uniform acceleration. Right, then the S, if I write in any of the equation, it is the displacement measured from the starting point, right, where the motion actually has begun, right? So this is the displacement from the starting point. Whereas now actually you see this S actually corresponds to where the particle was at t equal to 0 corresponds to the starting point. So starting point means it is t equal to 0. right? From there, if I measure the displacement, that is S. Okay, but whereas we have some other equations as well, something like S1. So S1 is something like displacement measured from uh, any other point which is not a starting point. Okay, so this is S1 is the displacement from any point, let me say P, right, other than, which is not, right, which the point P is not or other than the starting point, other than the starting point. All right, so if I write S naught, then I have a specific meaning for that. So in the S1 case, in this equation, you can see that we have used S naught. So this S naught basically refers to the displacement of the starting point from P. In the sense, P is somewhat away from the original point or the starting point. So that is the distance, displacement between the starting point and P. So S naught is the displacement that is between point P and the starting point. Okay, so that is S naught. And we also have a ST over there, right? This is the total displacement. All right, I can call simply displacement. Right. So we use all these equations and with the respective meanings of the variables to solve some of the basic problems now. So the problem number 1 under this case is as follows. A ball is thrown upwards from the top of a tower. Tower's height is 40 meter high with velocity 10 meters per second. So the question is find the time taken to hit the ground. Right? So normally, unless and specified, you can take G as 10 meter per second square. This is the closest value, right? Rounded off value. All right. So I know that I have to use a convention. You are throwing upwards, right? So you know that the initial velocity, that is with which you are throwing, is plus 10 meter per second. U is 10 meter per second. And acceleration is downward. So according to the convention, something that is towards ground is negative. So this is minus 10 meter per second square. Right. Now, if I consider this is the height of the tower, the ground is here, right? So I have to move downwards. So to reach the ground, So the height or the distance that you are going to travel. So distance traveled is denoted as the S, correct? So I can write it like this. So the S is equal to minus 10, not minus 10, sorry, minus 40 meters. Because the height of the building is given as, height of the tower is nothing but 40. So from there you throw upwards, it goes to a peak point and starts coming down, and it will it will hit the ground which is over here, right? So you can see that the distance covered in this case is minus 40 as per our convention, right? So let's put the equation, right? We know that we use this equation, that is S is equal to, you can use any of the equations to get the answer, but I think this is more suitable. S, distance covered, is equal to initial velocity into time plus half into AT square. Substitute, distance covered is actually I'm supposed to reach minus 40. Right? So U is given as a 10 upwards into the time plus half. What is A? A is equal to minus 10 into T square. So the equation becomes, let's bring the terms to the left hand side. So this is 2 5s are 10. So this is minus 5 becomes plus 5. So 5t square minus 10t minus 40 is equal to 0. All right. So let's solve this equation to get this. So let's take 5 common. So t square minus 2t minus 8 equal to 0. Right? So this gives you an answer. T is equal to minus 2 or plus 4. So time cannot be negative. So it is 4 seconds. Right? Is the required answer. Next question. A ball is thrown upwards from ground with the initial velocity u. The ball attains a height of 80 meters two times with the time interval of 6 seconds. So find u is the question. Once again, we are going to assume g is equal to 10 meter per second squared. So the point given here is that when we throw a ball with certain velocity of u as initial velocity, right, it moves up, reaches a maximum height and comes back. So it reaches a specific height 2 times. That height is equal to 80 meters, right? So starting from, let's say this is 80. Okay, this is 80 meters. This is say ground. Right, when you throw a ball upwards like this, it reaches a height, and when it comes back, right? You see the 80 is reached twice. So if this is the time t, this will be time t plus 6. This is what has been given. So the interval between the ball crossing the height 80 is 6 seconds, right? If you consider any time t as the first time it is reaching the height of 80, the next time it is going to cross after 6 seconds. This is the given data. Now the question is to find u. Okay, now let's start with this. So u is as given, it is u itself. So u is equal to, let's use u. So what is the acceleration? This is a, right? So when I throw upwards, positive, but acceleration due to gravity is downward. So this is minus 10 meter per second square. And we are talking about a specific height that is equal to 80 meters. All right, so let us try to write equation. So the equation that I'm going to use now is, once again, the S is equal to ut plus half 80 square. So 80 is the height, u is the initial this thing, t is the time, minus this is half into 10 into t square. Right, so this can be written as 80 is equal to ut minus 5 t square. Okay, so I can rewrite this as 5 t square minus ut plus 80 equals to 0. That 6 seconds is the time between it is crossing 80 meters and it's not the total time. Okay, so you see it crosses 80 at t, and it comes back once again crossing the 80 at t plus 6. So we don't know what is the t. Right, so right now I'm trying to calculate how much time it takes to reach this t. From ground to this is t. Right, so that's what we are using here. 5t square minus ut plus 80 is equal to 0. Okay, so now let us solve for t, right? So t should be equal to, right, this is minus b, so minus of minus u is plus u, plus or minus root of b square is u square, right, minus 4 into 80 into 5, 800, 1600. Okay, whole divided by 2 into 5, that is equal to 10. Okay, this is the case. Now we actually have two answers, right? I will write the t separately. So actually t is equal to either u plus root of u square minus 1600 divided by 10, or the other one is u minus root of u square minus 1600 divided by 10. Okay, so this is the first time t. The second time is this t is nothing but this is the other time, right? That is this. The second time t plus 6, right? So first time it crosses 80, right? At the time given by this equation. This is the first time crossing. This is the second time crossing. They already have given you the data saying that the difference is 6 seconds, correct? Right? The time taken to cross 80 for the first time and cross the 80 for the second time, that time gap is 6 seconds, right? So what is given? The difference is given. So this implies the first time is u plus root of u square minus 1600 by 10 minus the second time, right? That is u minus root of u square minus 1600 divided by 10. This gap is given as 6, right? So time difference between the two uh, times, right? The time interval between the two times is nothing but 6. Now let us try to calculate what is this. So this becomes, so the u and minus, okay, this is the common denominator, so I can simply write u plus root of u square minus 1600 minus u, minus of minus is plus, root of u square minus 1600 equal to, I can write as 60, right? The 10 can be taken to the other side, common denominator, that is equal to 60. All right, so u and minus u will cancel. So 2 times root of u square minus 1600 is equal to 60. So 2 cancels this as 30. So I can say that therefore I will square both sides. All right, so that is u square minus 1600 equal to 30 square, which is 900. So u square becomes equal to 2500. So as per this, u should be equal to plus or minus root of 2500, that is plus or minus 50 meters per second. Okay, so I have to ignore the minus sign here because I am throwing upwards. Upward is, according to our convention, positive. So the final answer, u is equal to 50 meters per second. If you throw with this, right, the conditions will be met. All right, then let's move ahead. Let us consider some points we should consider when we solve few more types of problems under this case. Right. So the first point is that if a particle is projected upwards with velocity u, then I can say the maximum height denoted as h can be calculated as u square by 2 times g. Right? Now, in this particular flight, the time taken to reach this maximum point, right? So that is called as time of ascent. That will be equal to the time of descent. Okay, this is directly equal to u by g. So since the time of ascent and time of descent are same, the total time is equal to time of ascent plus time of descent. So u by g plus u by g, that is 2 times u by g. Okay, this is when you throw something from ground and you throw upwards. Okay, then the second point is the reverse. So you are releasing the object from a height h and initial velocity is 0. U is equal to 0, right? So if a particle at rest, that is u equal to 0, right, is released okay, let's talk about the height. So from height h, all right, then I can say This implies velocity of the particle at the time it hits the ground. Okay, that can be calculated. Velocity at the time of hitting the ground. That is V is equal to root of 2 into G into H. Okay, and we have only time of descent now. This is equal to 2H by G under root. All right, so there is one point to remember. The air resistance has been neglected over here. So normally we don't consider that. So these equations hold pretty much good almost every time where we neglect the air resistance. Okay, then all right, let us calculate uh, the distance and displacement under two different cases. Okay, so this can be considered as next point. Point number 3 under this case. Right. So when we actually consider a motion where u is either 0 or parallel to a, right? If u equal to 0, either that is the case, initial velocity is 0, or u is parallel to the acceleration a, right? This is not upwards or downwards, it's in general. Okay, right. Then the motion is simply accelerated, and in this case, right, distance and the displacement both are same, right? If that is the case, if somebody asks you find the distance or find the displacement, you use the same equation. That is, distance is equal to the displacement, s is equal to simply ut plus half at square. Straightforward equation. Okay, then let's go to a different case. This is fourth case. So if u is not parallel, so it's anti-parallel, right? Anti-parallel to a, right? Then what happens? Motion is first retarded and then accelerated in the opposite direction. So it's actually moving in this direction. It moves, it stops, and then starts moving in the opposite direction. So you see, displacement is different, distance is different in this case. So what do? So let us calculate. If this is the case, u is anti-parallel to a, then displacement s is still calculated using the same equation, that is ut plus half at square. But the total distance covered, okay, distance d can be calculated as, I have to use a different equation, that is u square by 2a magnitude plus half of magnitude of, this is a times t minus t naught square. So let us write what are the parameters or the variables over here, right? U is known, A is known, acceleration, T is actually the total time taken. Okay, all right. So let us say here the T naught is the time taken by the object to attain velocity equal to 0. Because it is moving in one direction, it actually decelerates. So velocity keeps on reducing. When velocity reduces, velocity has to reach 0, right? How much time it takes to that reach 0, right? That's T naught, right? And then T is any time. Okay, any other time. All right. Now, let's move on to the next question, which is based on these concepts. The first one is a particle is projected vertically upwards with velocity of 40 meters per second. All right. Now the question is find the displacement and the distance traveled in, say, part A of the question, 2 seconds. Part B of the question, 4 seconds. Part C of the question, 6 seconds. Okay, so we are using 3 different values of time to calculate the distance and the displacement. Now, normally the T naught is the time taken to reach the maximum height. So that is time of ascent, which itself is the time required to make the velocity 0. This is because in this given problem, the u is equal to positive, that is 40 upwards, right? So that is a positive quantity, and a is downward, so this is negative, and let's take this is minus 10, right? So T naught is equal to, T naught is nothing but, as per our previous discussion, time taken to reach 0, velocity becoming equal to 0. This is magnitude of u by a. So let me make a point in the previous notation itself. So this T naught can be simply calculated as magnitude of u by a, right? So same equation I'm going to use now. So u by a, so this is, you take only magnitude, so that is 40 by minus 10. Magnitude means only answer is always positive, so this is 4 seconds. Okay. So when the time is less than 4 seconds, distance and displacement are same, right? So I can simply write like this. So if time is less than t naught, right, distance and the displacement s are same. So calculate, that is equal to, let's calculate distance, or is equal to ut plus half at square, right? So that is u is 40 into 2 minus half into initial velocity of 10, sorry, a is 10 minus 10 into the time of flight is 2 square is 4. Okay, so that is 80 minus 20, so this is 60 meters. So in 4 seconds it covers 60 meters. Okay, this is when t equal to 2, right? Also, I have to cover t equal to t naught, right? So t equal to t naught also same thing. So this is t equal to 2. Distance and displacement are same. Then t is equal to 4, right? In this case also distance and displacement are same. D is equal to S is equal to, once again, ut for t into time is now say 4. So ut minus half into 10 into t square, so 16. Okay, so this becomes 80 meters. So at 4 seconds, it reaches a height of, the distance and the displacement are same, which is equal to 80. All right. But when, now you see, whenever the t is greater than t naught, right, the distance and displacement are not equal. So you need to calculate both of them separately, right? First, let's calculate S. S is equal to ut 40, time is equal to 6. So you see here t equal to 6, which is greater than t not equal to 4. So in such case, I have to calculate them separately. So ut minus half a is equal to 10 into t square, 6 square, that is 36. All right, so this comes to be 60 meters, right? The object will be at a height of 60 meters when the time is equal to 6 seconds. But you calculate the total distance now. So distance d is equal to, that is u square by 2a magnitude plus half of magnitude of a into t minus t naught the whole square, right, is what I am supposed to consider. So this is magnitude of u 40 square by 2 times a. So this is 2 into minus 10 becomes simply plus 10. So that's why it is magnitude plus half magnitude of a is minus 10 becomes plus 10 into sorry, the current time t is equal to 6 seconds and t naught is 4 seconds whole square. Okay, so let's calculate this quickly. T square by, turn to this, 10 plus 5 into 4, 20. So 80 plus 20, so that is equal to 100 meters. So the distance, total distance covered is 100 meters in this. So that is the basic difference between the distance and the displacement. Okay, then let's move further. The next concept is, this is one dimensional motion with non-uniform acceleration. So acceleration keeps on changing whenever you consider the motion. Okay, now so first we consider the equations of differentiation, right? The first one is the velocity. Velocity is equal to ds by dt. S is the motion, the displacement, t is the time. So rate of change of displacement is the velocity, or this is also equated to dx by dt, provided the direction is in along x-axis. Also, we can write the acceleration a as dv by dt. All right, so that is one type of representation, right? But there is another type of representation. These are the two equations. The third equation can be acceleration, which is dv by dt, can be represented as the ds by dt, rate of change of displacement, into dv by ds. So originally ds cancels, you still have dv by dt, but mathematically you cannot cancel. Okay, right. So what is ds by dt? Ds by dt is velocity v. The first differentiation is v into dv by ds is the third equation which we can use, right, whenever the acceleration is not uniform. All right, then next we will consider the equations which contain integration. Right, here, so we obtain them. V is equal to ds by dt. So this implies ds is equal to v into dt. When we have such ds and dt on both sides, I can do an integration. Integration ds is equal to integral v into dt. Right? So that means, right, you can obtain integration ds as s. So this implies s is equal to integral v dt is one such equation. You see, it actually uses integration, so it falls under the second category, equations with integration. Okay, let's move to the next equation. The second equation, and in terms of integration, we obtain starting from the equation of acceleration. So acceleration a is equal to dv by dt. Okay, so this implies if you want dv, that is equal to a times dt, take integral on both sides. That implies integral dv should be v is equal to integral a dt. This is considered as the second equation which uses integration to solve. Right. Right. Then the integration v dt is displacement. Right. I can actually use another function here, that is the third equation. We actually wrote another equation that is equal to acceleration is equal to v times dv by ds. From this I can actually write a times ds should be equal to v into dv, right? So taking integration on both sides, a ds is equal to integral v dv is the third equation, right, which uses integration. Right, we may use the first set of equations that is the equations using differentiation or equations using integration as per our requirement. So if integration is feasible, we can go for equations using integration. Otherwise, we can stick to the equations with the differentiation. Okay, let's move on to the problems based on these concepts. The displacement of a particle moving along x-axis is x is equal to 20 plus t cube minus 12t. Right. So part A of the question, find the position, comma velocity at time t is equal to 0. Okay, then B, find whether the motion is uniformly accelerated or not. All right, then part C of the question, find the position of the particle when the velocity is equal to 0. Okay, so the question has 3 parts. Let's start with the solution of part A of the question. It says that put t equal to 0, calculate its position as well as the velocity. So the distance or the displacement x is equal to 20 plus t cube minus 12 into t, right? So position means at t equal to 0, calculate x. So x is equal to 20 plus 0 cube minus 12 into 0. So that is equal to 20 units being meters. So if you want to calculate velocity, that is dx by dt. Differentiate this. So 20 differentiation is 0 plus t cube differentiation is 3t square minus 12t differentiation is minus 12. So differentiate and put t equal to 0. So the velocity at the t equal to 0 is nothing but 3 into 0 minus 12. So this is equal to minus 12 meters per second. So minus indicates that the object is moving towards the left of the x-axis, minus negative x-axis. Okay, so that's the convention and we are getting the answer minus 12. So that is a part A answer. Then let's go to the part B. This is actually part A. So the part B answer starts like this. So it says that whether this particular motion which we have defined here, correct? Is it uniformly accelerated or not? In the sense, acceleration is a constant with time or acceleration varies with time. So to identify that, I have to get the acceleration. A is equal to dv by dt. So V is there, right? V is 3t square minus 12. Differentiate that, you get 3 into 2, 6t. When I'm saying acceleration is equal to 6 into t, it can be seen that as the time changes, acceleration is also changing. Acceleration is not a constant, right? This is not a constant, not a constant. So as velocity is not constant, my conclusion is that the motion is not uniformly accelerated. It's not uniformly accelerated. Okay, then let's go to the third part. Find the position when the velocity equal to 0. So they have mentioned that, right? Velocity becomes 0 at some point, right? What is the distance? Find x, right? But x needs time, right? I don't know the time when v becomes equal to 0. So for that reason, put velocity equals to 0. So velocity has an equation. We already know that, that is 3t square minus 12, right? From where you are getting it from here. So put this equal to 0, and once I make the velocity equal to 0, I am able to calculate the time now. So this is 3t square is equal to 12. So t square becomes equal to 4. So t is equal to plus or minus 2 seconds. So minus 2 is, once again, it's not a feasible answer. Time is not negative, right? So we take only positive. So time is equal to 2 seconds, right? So at t equal to 2, right, we know that velocity becomes equal to 0. So therefore, find x, find the displacement when x is equal to 2. So substitute 20, this is plus t cube, so t is equal to 2, 2 cube, minus 12 into t, so 12 into 2. All right, when we simplify, we get x is equal to 4 units meters. So the displacement is 4 meters when the, what you call, velocity becomes equal to 0. Okay, let's move on to the next question. The velocity of a particle moving in a straight line is v equals to 10 plus 2t plus 3t square. All right, so we have to find the following. Part A of the question, displacement from mean position at t equal to 1 second if the displacement is 20 meters at t is equal to 0. In the sense, at t equal to 0, it was 20. What is the displacement when t equal to 1? Right? That's the first part of the question. Then part B of the question, equation of acceleration. All right, now okay, the velocity is ds by dt. That's what is given. Okay, so displacement is given in terms of velocity. So v is equal to 10 minus 2t minus 10 plus 2t plus 3t square. This is nothing but rate of change of ds by dt. But my question is to find s now. All right. So s can be found by using this. Implies I can get ds is equal to v dt. Do the integration. Right. At the time t equal to 0, this is given as a 20, right? 20 till it reaches a distance s. So you can see this is how we try to do the integration, and the time is 0 to 1. These are the limits of integration. So the left hand side integration gives you s minus 20. At the same time, the right hand side is equal to, so I integrate this function. 10 becomes 10 into t plus 2 times t becomes t square by 2 plus 3 times t square becomes t cube by 3. So ultimately the equation that I'm going to use to substitute is 10t plus t square plus t cube. All right, so when I substitute to the right side, that is s minus 20 is equal to 10 into 1 plus 1 plus 1. So 10, 11, 12. So this is 12. So s is equal to 20 plus 12, that is 32 meters. That is the answer for the first part of the question, displacement from mean position at t equal to 1. Right, in this case you can see we are using the integration type of sets of equations. Similarly, then I need the part B answer. So part B answer is equation of acceleration, right? So we know that acceleration is dv by dt. So velocity is given, I just have to differentiate. So this implies acceleration is equal to, right, velocity is given 10, differentiation is 0, plus 2t is simply 2, plus 3t square is 6t. So acceleration equation is 2 plus 6t at any given point of time, right, according to this.